Welcome to the last session that we're going to be doing, which is on energy. Just to recap the ticker tape timers, what do? We get a ticker tape timer. It's got A, B, C, D, E's on it, with distances that are given in between. All right? What do? We draw a line all the way down from A, B, C, D, E. We draw them all the way down to give us workspace in between. Then we say to ourselves, right, in the things that we're looking at, we look at frequency. They give us the frequency of the timer, which is the da-da-da-da-da-da thing, right? Then we say, look for groupings between so many dots, or every 20th dot, or whatever. Calculate the time between each dot, which is 1 over the frequency, which is normally 0.0 something. Then multiply it by the number of dots, or the number of dots between the A's and the B's. Then we change the distances between A and B to meters. B and C, we change them all. Then we fill in delta T between each A, B, C, D, E, each time gap, right? So, what are we doing? We're doing this process here, correct? Okay. We are doing this process here. We've been given an A, a B, a C, a D, and say an E, right? We say A, B, C, D, E. I'm just recapping this stuff. We draw a line. Remember, we've already worked out what delta T is going to be up above. So now we know delta X1, delta X2, delta X3, delta X4 in meters. Then we write delta T. Okay? Can you see? I label it like this. And what do we know about the delta T's? They're all going to be the same. Okay? Right? Because it's the time between each, say, 20th dot in this case. Right? Now, we read the question. If they want velocity average between AB, it's VAB. It's the average. It is, in other words, delta X1 over delta T. If they want the average velocity between D and E, VDE is delta X4 over delta T. Right? And basically that's that. Then they might say calculate the instantaneous velocity at, let's say at, I don't know, at C. That is V at C. What do? We use this whole delta X2 plus delta X1, 3. It's the total distance from there to there, correct? Divided by the total time. And the total time is going to be what? The total time is going to be delta T plus delta T. Right? That gives us V at C. I don't know, let's say they wanted V at D. We would go from there to there, wouldn't we? V at D would be delta X3 plus delta X4 over delta T plus delta T. Then they say they want acceleration, all right? Acceleration, and we say, okay, acceleration is delta V over delta T. What do? We find two known V's. Let's say we're going from the red to the red. So we're going to go from here to here. We say it's going to be delta V is velocity at DE, which is this one, minus velocity average AB, okay, this one, divided by delta. Now what is delta T? Delta T is going to be this time here, right? There, 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 and there. And remember, from here to here is half. So it's going to be delta T plus 2 half delta T's. So it's going to be delta T plus delta T plus delta T is 3 delta T. Right? We could also have worked out the acceleration between there and there, because we know VC, V at D, therefore the acceleration V at D minus V at C over, and in this case, delta T is just that piece, isn't it? It's the normal delta T. So we find the two velocities and we work from there. All right? That was just a recap of the of those things. Let's just move on now, right? Let's look at the last section of the work, which is energy. Energy, very important section. It comes up big time. Next year, big time, grade 12. Lots and lots of work on energies that we've got to do. Okay. Well, first of all, they give us two types of energy that we're going to deal with here. Type 1 is going to be kinetic. Doesn't matter the way it gets introduced. And type 2 is called gravipotential. Energy. Okay. Well, let's have a look. What does kinetic energy mean? Kinetic means what? Kinematics, movement. So, if something is moving, it's moving energy. And the formula is EK is equal to a half times mass times V squared, velocity squared. What is the measurement of energy? Measured in joules. Okay? Joules. Kilogram meters per second squared. Meters squared per second squared. Right? How did I get that? Well, M is equal to kilograms. V is meters per second. So, therefore, it's kilogram meters squared per second squared if I square velocity. Right? Gravitational potential energy is energy because of height. Okay, height. Hello. Let's just have a look at this here. That's got potential energy. If I hold this over here and drop it, it's got the height energy there to there, isn't it? Right? And this is measured as EP is equal to mgh. Mass times g, which is the acceleration due to gravity, which is 9.8 meters per second squared. Right? So, what have we got? We got a potential energy. I'm holding it up. It's got potential. Potential means he's got potential. She's got potential to be a great artist. She's got the possibility. This has got potential energy. It's got possible energy. If I let go, it's going to come down. And let's think, if I drop this from 5 stories above, it may well be a very soft little spongy ball, but when it hits you on the head, it's going to hurt. Okay? Because of its energy. It's building up kinetic energy. It has got a lot of potential energy when it's got a height. Right. The last thing is, well, not the last part, but now we have to define something called mechanical energy. Mechanical energy. All right? Now, I know I say it all the time. Please remember laws of energy, definitions. Those you've got to learn. They will be always in tests and exams. If you haven't come across it already, they're going to be there. Okay? So please learn them. I mean, it's worth 2 or 3 marks every single time. And there's a lot of them. And a lot of them next year. And a lot of them in the year after. And, yep, a lot of them even advanced. You've got to know them. Mechanical energy is defined as EP plus EK is going to be E mech. All right? EP, the potential plus the kinetic. In other words, the total energy of the object. All right? If it is a ball high up in the air being held by me, it has got no kinetic energy, but it's got potential energy by virtue of its height. All right? Now, the last bit before one does an example of these is the law of conservation of energy. Of energy. Okay, what does it mean? Simple. It means the energy that you start with must equal the energy that you end with. Okay? If only that were the case. Imagine if you could end a race with the same energy you started with. but unfortunately it doesn't work that way. So what do? We say, okay, the conservation of energy means that at any point, right, when I start off over here, I go through processes and things and end up over here, the energy, the total mechanical energy here must equal the total mechanical energy there. There is no loss of energy and there's no gain of energy, okay? Energy cannot be created nor destroyed, merely changed from one form to another form, okay? We've got these laws of conservation right throughout physics and chemistry, all right? Law of conservation of energy means that E mech at one point must equal E mech at another point. Well, what does that actually say to us? It says, okay, it says if you've got a system, let us assume that we have a ball, okay? All right, let's assume it's a ball, and for argument's sake, it's a tennis ball, or no, it's a 10 kilogram ball, right? So, in other words, it's one of those medicine balls you throw around in a thingy. I am holding it up here, and I am going to be 20 meters into the air, all right? Now, you're already saying, heck, I don't want to be the person standing at the bottom there if that thing falls, because yes, it will crush you. What happens when I let go? The ball drops. Why? What brings it down? Gravity. The acceleration due to gravity, the force of gravity. The force of gravity is mg, isn't it? Mass times acceleration, and g is 9.8 meters per second squared, always. What do we do next? We say, okay, in all of these problems, step one, draw it, okay? If they've given you a drawing, use it. What have we got here? We've got H equals that. Over here, we've got V initial equals 0. Over here, V final equals we don't know. All right? Now, using the laws of conservation of energy, what you do is you say, right, E, P at position A and position B. You split it up into discrete parcels, discrete pieces. Quanta, remember that from quantum energy, quantum mechanics. We split it up into pieces, all right? So A to B is our first consideration of motion in this case. You'll see why I say that when we do the next one, which is a roller coaster one, all right? So we say, okay, that's that. Now we start off, we look at EP at A is equal to mgh, which is 10 times 9.8 times 20, which is equal to 1960 joules. Okay? Then we say EK at point A is equal to a half times 10 times what? Times V squared. V is what? It's 0 squared is 0. Then we add them, and we end up with E mech. E mech here is 1960 joules. Then we go to the next point. We go to B. What is EP here? mgh. 10 times 9.8. Height is now 0, which is 0. We go to EK is equal to a half mv squared, which is going to be a half times 10 times v squared, which is 5v squared. We don't know v, but just hold on. We're going to work it out. How? Well, what does the law of conservation of energy say? It says that E at A, the mechanical energy at A, must be equal the energy at B, because I haven't lost or gained energy in between A and B. We're going to look at situations where we do it, where we lose or gain energy when we get to grade 12. So what's next? Well, sometimes it might be done in 11, depending on how your teacher's going about it. Okay, EA equals EB. We put them equal. All right? We say, okay, therefore, E at B or E at A, it doesn't matter. 1960, which is E at A, must be equal to joules, must be equal to, oh, what's my total energy here? Is 5v squared. Must be equal to 5v squared. But now I can solve for v. Therefore, V is going to be equal to the square root of 1960 divided by 5, which I think comes out as 19.8 meters per second. Right? That's first way of doing it, using the laws of conservation of energy. Please do not use Newton's laws if they ask you. But using Newton's laws, what have we got? V final equals V initial plus A T, right? Well, we don't know T. We can also go V final squared equals V initial squared plus 2AS, delta X. Okay. Do we know V final? No. But we do know that V final squared, V initial is 0 squared. 2 times, what's A? 9.8, it's the acceleration. Delta X is 20. Okay, so what have we got? We've got that V final is going to be equal to 2 times 9.8, switch it on, times 9.8 times 20 equals that, and to the power of a half is going to be 19.8 meters per second, not squared, Kevin, just plain old seconds. Okay. So in all of these, right, we're going to do the same approach. Okay. Let us take, for example, let's take a roller coaster. Okay. Let's take a roller coaster problem. All right. Let's say we've got a roller coaster coming along here, and we go up and we go there, and we end off there. Then they give us some heights over here, right? This is, let's say, A, B, C, and point D. This is the station over here, let's say. Okay. Now, this height here is, let's say, 10 meters. Let's say our roller coaster is coming along here and it weighs 800 kilograms, loaded up, and it is traveling at the top at 5 meters per second. They say calculate V at B. Okay. They could say calculate V at C. Okay. Let's say over here, they tell us that this over here is 2 meters high. All right. Well, what do? Okay. We do this. I'm going to say over here is going to be, let's have a look first at V at B. All right. I'm going to fill in that. We can go back to C and make it a little more difficult. Let's look, what is V at B? What does the step say? It says, right, we are looking only now between A and B. We split it up into the chunks. We always look for the place where we've got a kinetic and a potential given, okay, where we can work them out. So we say, right, at A, EK is equal to a half times 800 times 5 squared, okay, which is going to be 400 times 25, isn't it? 400 times 25 is going to be 10,000 joules, which is also 10 what? Kilojoules, remember? Okay, EP is going to be mgh. Mass is 800 times 9.8 times height, 10. 800 times 9.8 times 10 is going to be 78,400 joules. Next step, add them. EMEC, okay, that's the total. 78,400 plus 10,000 is 88,400 joules, right? We now know. So now we go to B. At B, EP is equal to 800 times 9.8 mgh. But h is 0. Why? It's lost all of that height. It is on the ground. It's just passing by. This is called a datum. or a reference. It's where we start measuring everything from. Okay? So let's have a look there. We say, okay, there's that. Therefore, that's 0. EK is going to be what? Okay, it's going to be, let us say, EK is going to be a half times 800 times V squared. Oh, well, that is equal to, not 0, that is equal to 400 V. Okay, add them. So therefore it's E mech is going to be 400 V squared. Sorry, my bad there. Then what do? We put them equal to each other. Why? Because of the law of conservation of energy. Says we can. We haven't lost or gained energy. So we say therefore 400 V squared is equal to 88,400 joules. Therefore V is going to be equal to, okay, we divide both sides by 400 and take the square root. Divide by 400 equals that, and to the power of a half is going to be 14.87 meters per second. So it's got faster. Why? Well, it's gone downhill. That's what happens with a roller coaster, isn't it? It gets faster, right? That's what you'd expect. So if you look at these things, they're logical. That's what you'd expect to happen. Right, now, let us say, let's just take a different approach here. Let's not say that. Let us say that over here, they've asked us calculate the height that the station needs to be, all right? Because the maximum velocity that this train can come in at the station, okay? Let's say that then they say at D, let's have a look what they tell us. Maximum velocity at station is, let's say 5 meters per second. Okay, how high must the station be? So all we do is we say, okay, at D, let's calculate EP at D. Can you see the pattern? That's all we're going to do. EP at D is M times G times H, which is 800 times 9.8 times H, because H we don't know. Okay, it's going to be 800 times 9.8 equals 7840H. Right? And EK is going to be a half times mv squared, which is a half times 800 times, they've told us 5 is the maximum, right? So it's going to be 400 times 25 is 10,000. Okay, H. Add them. 7840H, okay, is that not H? 10,000 joules. I'm thinking of H in my mind. 10,000 joules, right? Because we've got it all. So it's going to be 10,000 plus 7840H. All right? What does that mean? What do we do then? Then we say that must be equal to, this is E mech. Therefore, we can put plus 7840H must be equal to 88,400 total energy, and work out H, okay? And equals that, and divide by 7840 is equal to 10 meters. Which is what you'd expect. It says to you that if you can only come in at 5, we started off with 5. See? So therefore the station would be the same height as we finished. I just wanted to show you that it doesn't matter, okay? It doesn't matter where we start either. All right? They could give us a roller coaster problem where we started at the end and work backwards. What do you look for? You look for where you've got a known velocity and a known height. That gives you the total energy at the start. They could tell you the total energy at the start, right? All you do is you fill it in, energy at A, energy at B, energy at C, energy at D, right? One last thing is the other energy type calculation, which is the pendulum. We have got a ball over there of 10 kilograms, let us say, right? And this ball has a height above ground of 5 meters, right? If I let go, what happens? The ball swings down. Can you see that that's potential energy changing to kinetic? Well, let's look. This is A, this is B. What is EK? This is, let's say, at A. Okay? EK is equal to a half times 10 times velocity 0 equals 0. EP is going to be 10 times 9.8 times 5. Okay? So it's going to be 10 times 9.8 times 5. 490 joules. So the energy up here is 490 joules. Now what happens? As I let go, it swings down and it reaches a maximum. This is V max. That's the fastest the ball's going to go. Why? Because as it starts moving up, what happens? It slows down, doesn't it? Until it gets to the top and then comes back again. It's a swinging pendulum. So any type of problem like this has got the same kind of solution. Then we say with energy at B, EP is equal to 10 times 9.8 times, what's the height? 0. EK is equal to a half times 10 times, do we know V? Nope, we don't know. So that's 5V squared. Now we put them equal because of the law of conservation of energy. We say 5V squared is equal to 490. Therefore, the velocity of this pendulum, divide by 5 and take the square root. 5 equals that. Okay, the power of a half, okay, is 490 to the power of 0.5 is equal to 22. Okay, so let's have a look again. Sorry, my bad. 490 divided by 5 equals that to the power of a half is equal to 9.9. All right. No, but they could have said, how high do I have to pick up the ball to get a velocity of 10 meters or 12? Okay. What do? You start with the energy, the EP and the EK, at a point that's known. I can start here because I know that there's no height, so my EP is 0 at that point. Right? Straightforward energy calculations. I hope you've enjoyed the sessions with me. I've enjoyed giving them, and I'm very passionate about this subject, as you know. But please go through, have a look, do the ones that we've done together, have a look in the test and exam section if you like. Do old papers. But all in all, at the end of the day, good luck with it. Please learn your theory. That's a very important point. All the calculations we're going to do, there's quite a load of them in the exam and the test prep section. But good luck with your exams, be it mid-year, be it finals. And I'm hoping to see you in grade 11 and grade 12. Who knows, maybe even in when we get around to doing the A-level sections as well. We'll see you there. Thanks for watching and cheers.